Hello students, I am your Anannya Ma'am from PrepMed NEET, and today we are going to understand the screw gauge. As you can see here, I am holding in my hand the screw gauge. Okay, so here in this case, this is the screw gauge, and here this is the linear or main scale of this screw gauge. Okay, so as you can see here already written 25 into 1 millimeter. It means that there are 25 small divisions in the linear scale where each division gives you the reading of 1 millimeter. Okay, so you can say that if you are holding this portion is known as what? This is ratchet, this is the circular scale, and this portion is known as thimble. So we are just holding and we are going to find out the total portion. As you can see, from 0 to 5 to 10, total how many readings are there? 25. After 25 you are getting the linear scale. Okay, so then you see the circular scale. Okay, here the circular scale starting from 0, and if you rotate like this, you will end up with 90, again 0. So total how many divisions are there? Total 100 divisions. So 100 circular scale division. Here in main scale you are having 25 millimeter. So now you are going to calculate the diameter of any cylindrical substance so that you can understand how to calculate the reading. Now I am going to calculate the outer diameter of this cylindrical body. Okay, as you can see, it is hollow, so you can measure the inner and outer both. Okay, so I am going to find out the outer diameter of the cylindrical body. Okay, before calculating that, we need to first get the least count of this screw gauge. Okay, so least count is what? Least count is the smallest measurement that can be done using any instrument accurately. So here first we need to calculate the least count. Least count is what? Least count is here pitch divided by the total number of circular scale division. What is pitch? Here you can see that if here this is the 0 marking of the linear scale, then for one complete rotation of the circular scale, the linear distance covered is known as the pitch. Okay, let us give one example. So say I am here at 5. Okay, now you see the circular scale 0 is just coinciding with the linear scale value. So linear scale value up to which value you can see here? 5. So if you rotate now the circular scale for 5 rotations, you are rotating, then you can get what? That is the pitch. But this is for 5 rotations. So we need to calculate for 1 rotation what is the linear distance. So that is the pitch. So total rotation is here 5. You are going to divide the linear distance by 5. So we are going to calculate, we are going to get the pitch. Okay, so I am just rotating here for 5 rotations. Okay, so 1, 2, 3, 4 and 5. If after 5 rotation the 0 of the circular scale and the linear scale both are coinciding, that means the pitch value is what? 5 millimeter divided by 5, that is 1 millimeter. Okay, so this is the pitch. So what is the least count? Least count is here 1 millimeter divided by total circular scale division. How many division? Just now we have calculated the number of division is 100. So 1 by 100, that is 0.01 millimeter or 0.001 centimeter is the value of least count of this instrument. Okay, so now we are going to calculate the outer diameter. So we are now placing this cylinder between this two parts. One is known as stud, other one is anvil. Stud and anvil. We are going to place this cylinder in between. Okay, not very tightly, just to hold it. So now what you will get? You will get both the main scale reading and circular scale reading. Okay, so let me check. So here, as you can see, what you can see here, what value of this main scale is visible to you? Okay, so here we can find out that last we are getting the 8 mark, that is 8 millimeter. Last the 9 mark we are getting, but the 9 mark is totally not visible. So as you can see, the total mark it's visible to us is number 8. So 8 millimeter is the main scale reading, and here you can see the 97th mark of this circular scale is coinciding with the linear scale. So 97 into the least count is what? 0.01 millimeter. So 0.97 millimeter is the circular scale reading, plus 8, that is 8.97 millimeter is the diameter of, this is the outer diameter of the cylindrical body. Okay, so this is the value. But wait, if the instrument has any error, so we need to calculate that also. We need to measure if the instrument is having any error or not. So let us find out. Okay, so how you will calculate the error? It can have both positive zero error or negative zero error. Zero error is what? Zero error is if the linear scale mark and linear scale 0 and the circular scale 0 is not coinciding with each other, if there is no body in between the stud and anvil. Okay, we are not inserting any object in between the stud and anvil. Then what happened? Then if the 0 of the linear scale and 0 of the circular scale is coinciding, then there is no zero. If they are not coinciding, then we may have positive or negative zero. Okay, so let me check. So what we are doing, look, we don't have any object in between stud and anvil. So just we are going to make this two in contact. Okay, look, here you can see the 0 is not coinciding with the linear scale. So here you can observe that the third division of this circular scale. Third division of this circular scale is coinciding. So this is which error? This is which error? Positive zero error. If we are getting this positive zero error, then we need to find out the zero error as the zero error reading, the division into the least count. This will give you the zero error, what? Zero error reading. So 3 into 0.01 millimeter, this is the 0.03 millimeter is the positive zero error. So here what we need to do is, we need to just subtract the value from our observed reading. What is our observed reading? Previously we got 8.97 millimeter, and then we need to subtract the value. Subtract the value of how much? 0.03 millimeter. Okay, so 0.03, if you are subtracting from 8.97, you are going to get 8.94 millimeter. This is the actual reading, corrected reading of this outer diameter of the cylindrical body. Okay, so this is the whole explanation that how we are going to use the screw base and how we are going to calculate either the diameter or the this diameter of or the diameter of a spherical body, etc.